Hey everybody. Today, what you can see on the screen is we're going to talk about simple interest. Now, this is a concept that deals with, and you can see at the very top of your screen, us talking about interest. Interest being the money that is paid for the use of money over a period of time. Now, that definition can get a little confusing when we talk about money that is paid for the use of money, but I think we'll get into it pretty quickly. What simple interest is like the basic unit, the fundamental way that we pay people or receive pay for the use of money. Simple interest is the basic way, the basic unit, in which all other interests are determined. So when we talk about other investments, we talk about other debts, simple interest is the basic way in which we calculate that payment for the use of money. So when you get into some uglier investments or debts in future years, this ends up being one of the basic concepts for us in financial math. So what I want to do is I want to talk a little bit about what is interest, some key components to it, and then we're going to focus in on some of the fundamental skills or know-hows that we need to be able to work with simple interest. Okay, we've got some definitions of some things on the screen. You guys take a look at that first bullet. If you deposit money into an account, then you are giving somebody else your money, then the bank would agree to pay you interest. If you borrow money from the bank, you're taking money out, then the bank charges you interest for the use of that money. So what interest is a payment for the use of money. And I'll get into that in maybe a little more detail in a moment. Let's talk about a couple key terms though. The first being, you see in purple, principal. Principal refers to the quantity of money, the amount of money that you are going to either deposit or borrow. So how much you put into the bank, if it's an investment, how much you take out, borrow, if it's a debt. What really gets confusing, though, is when you hear the term amount. Because amount just sounds like a total, like it sounds like just any amount of anything. But you have to be very careful. Specifically, the term amount, when we talk about financial math, refers to the total of the principal and the interest. So it is the quantity of money that was deposited or borrowed plus the additional interest. That is big for us. So when we see that and there, what we're talking about is we are adding on that interest. Okay, one other little side note, but it's very important. Interest rates are always quoted per year. Okay, per year. And the way you'll often see that referred to is per annum. So you have to get comfortable with that language per annum, but I don't think it should surprise us that annum refers to year. If you think about maybe some other terms like annual, anniversary, those would be two things that we would talk about on a yearly basis. Okay, I want to get into this concept of interest just for anyone where, we don't really have a firm grasp of what interest is. Okay, so what are we talking about when we talk about interest? Well, let's imagine that you have a bank, and here's your little door, and this is our bank. And what happens is you end up going into the bank, and you go and you decide to give them your money. Now, we'll talk about any amount of money that's going into your bank, money that's yours in blue. So let's just say then that we have a bank account, and we'll just call it that for simplicity. Then you go and you deposit that money into your bank. Now, by depositing your money into the bank, you and the bank have this agreement that you could come back and you could take your money back out and return your bank account to an amount of zero at any time you wish. That is an agreement that you make with the bank. Okay, where does interest come into play? Well, if I get rid of your bank balance again, and we say that you decide to go into the bank and give them your money, well then The bank has your blue money sitting in the account, but it's not like the bank agrees to just let it sit in your account. The bank wants to use that money. And in fact, it wants to use that money to make more money. So what the bank does is the bank now takes your blue money and it hands it out to other people. And when it hands it out to other people, it is going to loan that money to other people. And then the bank in turn wants to make money off of your money. And the way that they do that is by charging interest. So the bank charges other people interest to use its money, but then what you do when you decide to put your money in the bank pays you interest for the use of your money. And so there's this whole circle that happens of where the bank takes your money and it lends it out to other people. In turn, those other people pay interest. Then that interest comes around back to you when you then decide to give the bank your money. And it's this big circle of where everybody pays everybody for the use of money. Okay, what does it look like in practice? Well, I talked earlier about this agreement between you and the bank for the use of your money, and that the bank agrees to pay you for the use of your money, and they agree that when you come back to the bank and ask for your money back, they will give it to you. So, how does that all work? Okay, look back at my my white arrow with my blue dollar sign. That is you walking into the bank and you are depositing money into, let's just call it a generic account. You can say to the bank, I agree that I want to come into the bank tomorrow, to have the ability to come in tomorrow and get my money back. Now, if you want to come back tomorrow, then that means the bank doesn't get very long to use your money. So what the bank might say is the bank is going to give you a little bit of interest for the use of that money because they don't have a whole lot of time to use it. So I'm just going to use numbers here to comparatively talk about size. But maybe what the bank says is they say they're going to pay you 1% interest. So for every $100 you deposit, they would give you $1 extra in interest. Okay, well, there's different types of investments. Maybe you choose to go into the bank and you say, actually, you know what? I don't need my money back for a while. And maybe you say, you can hold on to it for a year. I will not come in and get my money back for a year. And so the bank then says, well, I've got a lot longer to try to lend out that money and make money off of it. So they might be willing to pay you 3% interest, a little bit more interest, because they have more time to be able to make more money from your money. Well, maybe there's things like GIC, and don't worry about understanding any of that terminology, but something where you're going to end up locking your money in for a little longer. Like maybe it gives you, like a 5-year term. Well, in order to agree, well, hey, I'm not going to touch my money for another 5 years. The bank then might say, well, you know what? We're going to pay you 6% interest, and so on and so on. The longer you are willing to give the bank your money, the more interest they would be willing to pay you. And that's how you start to see different types of investments. How locked in your money is your money into those time periods, which basically means how much longer does the bank have to make more money off your money? So that's the way that interest and investments work. You walk in and you give them that blue dollar amount and you set an agreement as to when you want your money back. You give the bank your money. The bank then might say, well, thank you for letting us use your money. We will now agree to pay you the pink additional interest. And so your bank account then becomes the total of the money you put in plus the interest paid by the bank. Okay, that is a very simplified version of the way interest works, but I think it really cuts to the point. All of those things get reversed if you decided to walk into the bank and ask for a red loan. I'll use red because red often refers to debt. That now the bank would be willing to to give you that money, but you would then agree, you know what, and I'm going to pay the bank some additional amount in interest as it takes me time to pay back that debt. The longer it's going to take me to pay that debt, the more interest I'm going to pay. Okay, I'm hoping that maybe clarifies a little bit the concept of interest. Seriously, I know it's going to sound weird, but I want you to picture that bank as if it was a store. And when you walked into that bank, you opened up the door and you saw these shelves sitting across the back of the bank. And on those shelves were money. And you walked in and you said, I would like to buy some money. And the bank says, sure, you can buy some money. Well, what's it going to cost you? It's going to cost you money. And so you pay for money with money, and that is interest. Okay, the more we can start thinking about money as just a good you would buy in a store, I think the easier it's going to be to consider the concept of interest. Okay, what I want to do now is I want to jump back to how we work with interest. So take a look down on your page. You see below on your page that I'm going to ask you to complete the table that I gave you. And I want you to take a look very quickly at what those headings are in that chart. So you can see that I've given you in the left column the principal. You can then see that I've given you the interest rate quoted per year. And then in the next column, I've given you different time periods. You'll notice that those time periods range from years to months to days. What I'd like to do is I'd like to go through together us calculating interest. You'll see that in the big wide column. We're going to figure out our interest amount, and then we're going to figure out the amount of our investment or debt. Okay, to make it a little easier to communicate about, to talk about, let's just consider that this is all an investment for you. So what we're going to talk about then is we're going to imagine you're going into a bank and you are going to give them money and you are going to earn interest. Okay, let's take a look at the top row. What I'm going to do is I'm going to take that top row and just for simplicity's sake, I'm going to label that as A, just so we can talk. Okay, for investment A, you're going to take $1,000, you are going to earn 5% a year, and you're going to agree to put your money in that account for 2 years. Okay, so how do we calculate our interest? Well, we're going to take our principal, which is $1,000. We have to then calculate 5% of it. Now, as we work with percentages, we should know that we never use our percentage. We always use our decimal form. And so hopefully we're good on our 5% being 0.05. But that 5% was earned for 1 year. So since the investment is going to sit for 2 years, we need to double that, multiply that by 2. Okay, this would be the sort of thing that I would expect you to be using a calculator for. That is no problem. But we could go through and we could calculate that, and we should come up with $100. I want you to make sure your keying sequence gets you to 100. So what does that make the amount of our investment? That would be the original 1,000 plus the interest of 100, so 1,100. There we go. Hopefully not too bad. Okay, what I would like you to do is to tackle the next two rows. So again, for simplicity, let's call that, and let me just get rid of that color there. Let's call that row B and row C. And let's make sure that we can match up with the same thing. So I want you to go ahead, try this on your own. We'll pause the video and we'll see if we match up. Okay? Pause it now. Okay, we're back. So let's check on row B. For us to make our calculation, we should be good to say that we're going to take 2,000 and we are now going to multiply that by our 5% interest. And we are now going to multiply that by 3 years for the investment. That is going to get us up to a $300 interest. And if we earn $300 interest on top of the $2,000 invested, then our investment is now worth $2,300. Hopefully we match up. Okay, if we hit a snag with that one, I'm hoping we can correct some things, give C a shot. Otherwise, you're coming along with me. So we should be taking our $3,000 investment, multiplying that by 0.04 for our interest rate, multiplying that by 5 years that our money sits in that investment. If we work on our keying sequence to that, we should see that we get an interest of $600 earned. And if we go back then to our total investment, that is going to give us $3,600. Okay, hopefully we're good with those calculations. Okay, what I want to work through now together is D. I want us to go ahead and tackle row D. So let's take a look. We have a principal of 2,000, an interest rate of 7%, and the time frame is 6 months. Okay, I'm going to do this nice and thick with my pen. The most common mistake you guys are going to do is to type in 2,000 times 0.07 times 6. Now, I want you to take a look at what I just entered into that chart, and hopefully you can see why that's incorrect. Now, if you can't, then calculate the interest based on that calculation, and then you got to ask yourself, okay, wait a second. How am I earning so much more interest? Was it the 7% because I'm getting a highest interest rate? How? I'm only investing for 6 months. That's not even a full year. And hopefully then we can see our mistake. Now, there are a couple things. I recognize that we are going to have some decimal junkies, and I'm going to tell you, you want to get out of the habit of being a decimal junkie as fast as possible. If we recognize, and I'm going to erase it, that multiplying by 6 was our mistake. We multiplied by 6 years, not 6 months. Then since our interest rate is always given per year, we need to always write in our time per year. Well, then what's 6 months as a year? We may be tempted to say 0.5 because we're a decimal junkie. And I'm going to tell you, stop. Don't use decimals in that case, because what happens if the time frame I give you doesn't work out to be a nice, neat decimal? We need it to be exact. So let's get used to using fractions. You could write, well, 6 months is 1/2 of a year. And I would love to see that. I'm just going to tell you, I don't think you need to. I wouldn't be worried about it. Don't worry about reducing your fractions to lowest terms. It's not your final calculation anyway. So if I were you, I think what I would do is I would end up using 6 months out of 12 months. That being my half of a year. And I'll just keep it as an unreduced fraction. Now I can go ahead and I can calculate that. Look at that purple row I just wrote down and look at all your operations. You should be able to see you have multiply, multiply, and divide. And so according to BEDMAS, if all I have is multiply and divide, I can pick the order I want to do it in. Then you should be able to just type all of that into your calculator in one go. 2,000 times 0.07 times 6 divided by 12, and we can go straight to a calculation of $70. Okay, I want you to make sure that in your keying sequence, you can get down to that 70. Okay, if that's the case, then filling in our last column is pretty easy, $2,070. Okay, I want us to now go through, if we want to call them row E and row F, and we'll see how we match up. Okay, I want you to pause the video and see if you can get down to an amount for both. Okay, pause it now. Okay, we're back. So I want to take a look at row E. If you were to go through E, I would hope that it was pretty automatic. We just didn't make a silly mistake. We are taking 1,500. We are now earning an interest rate of 7.5%. That would be 0.075. Make sure that we're converting that percentage into a decimal properly. If we're now going to invest for 3 years, that one should have checked out okay. Okay, what does that mean for interest? Well, that means that I make an uglier amount of interest, but a more realistic. $337.50 is what we should match up with. Make sure your keying sequence gets you there. What does that mean for a total amount of interest? Well, then that's $1,837.50. So yes, we can start to get some ugly amounts of interest. Since we're talking about money, how many decimal places do we need to round to? Hopefully we're good on 2, and we should be okay with that. Okay, I left you with F. F is the one that we're going to have a hiccup on, but I want us to be very clear about why. I think everybody should have been okay to go through and say, well, I'm going to invest $800. The interest rate of 5% should have been automatic. We've had practice with that before. Here was your potential mistake. Okay, you need to invest it for 90 days. So you just had to think about, well then, if it's 90 out of what? How many days are in a year? And let's make sure that we're using 365. Now, can we please make sure that we recognize 365 days in a year? And I don't want to hear anybody go, yeah, but wait a sec, what if it was a leap year? What if it was 366? We don't. It's 365 days for your investment. Make sure that we are good on that. Okay, if we've got that for the purple, then we should be good to go ahead and push some buttons and make some calculations. So check your keying sequence, check your rounding, and make sure that we're coming down to $9.86 worth of interest. If we have that in terms of our interest, then add it to your total, and we should come down with $809.86 as our total investment, our amount. Okay, I want you to take a look at the 3 rows, A, D, and F, that I did in thicker marker. Those, I think, should have been our challenge. I think the rest should have been pretty automatic as we went. Okay, those calculations for us. I'm hoping that getting used to calculating interest is going to become a pretty comfortable thing. What I want to do now is I want to actually talk about a relationship with it. I want us to see a faster way to get there. And then I want to talk about some of the fundamentals for us to calculate, to consider. Okay, one quick question before we move forward though. If I was to ask you the question that you see on the screen right now, which interest rate is usually higher? The rate you receive for money you deposit or the rate you are charged for money you borrow, and why? I want you to take just a moment to consider that. Pause it if you need to, but I want you to come back with an answer for yourself and we'll check and see how well we did. Okay, pause it now. Okay, hopefully we're back. Which interest rate is higher? The money you receive when you deposit or get charged when you borrow? I hope it's the amount that the bank charges you. And I hope it was a pretty quick consideration. Just imagine if the amount of money that the bank paid you was more than what they charged you when you borrowed. If that was the case, that bank that we talked about earlier, you know, that nice door that welcomes you in to pay your money, it's going to go out of business pretty fast. Our bank would go bankrupt. Okay, we were talking about some fundamentals. We were talking about a relationship. Maybe I can help you out with a bit of a relationship or a formula, if you want to consider it that way, moving forward. Okay, I want you to take a look in your screen now. What you'll see is a formula for how to calculate simple interest. I would hope going forward, we're good that we don't really even need this formula. That is, it's kind of a concept for us, like it's a relationship that we're just comfortable using. But if you want to think of it as a formula, feel free. That formula, that relationship, you can see is I equals PRT. And there are some things in financial math that show up time and time again. Okay, we've got an uppercase I for our interest. That's a pretty common notation. You'll notice our uppercase P represents the principal. That is a very universal notation. You can see that lowercase r that happens to represent your interest rate per year. That is very common. And then it shouldn't surprise you that T is going to represent time, but again, in years. So for us to calculate our interest, we need to take our principal times our interest rate and then multiply that by the time in years. Now, what you'll notice is we were actually using that relationship the entire time we filled in that chart. So it's not a formula we need to memorize. I'm hoping it's a relationship that we actually understand. Okay, if we are going to use that relationship, then there's some fundamentals that we want to make sure we are good with. So we're going to maybe take a step back a little bit just to make sure that we're comfortable with some of the mechanics. Okay, I want you to take a look at your screen right now, and I want you to take a moment to try these on your own. This is going to be a moment for us to see, are we missing some concepts from the past with regards to some numeracy? You'll notice I've asked you in question 3 to express the following percents as decimals. So you need to change each one of these percentages into decimal form. So that's what I'd like you to do. I want you to pause it now and see if we are good. Okay, pause it now. Okay, we're back. So just a couple quick checks. I would love it if we had our answer of 0.09. Now, a couple things for us to consider. First off, I hope that we're good that all percentages are out of 100. So you can get rid of your percentage symbol and write it out of 100, but then we need to calculate that. So you're going to have to calculate 9 divided by 100, and that's going to give us our 0.09. For form, can we make sure that we don't ever write that as 0.09? That's often referred to as a naked decimal. And we don't like writing it that way. That's just kind of bad form. So let's make sure that we keep the place value in there with our 0.09. The second thing, I think a lot of you will have in your back pocket that multiplying or dividing by a factor of 10, like 100, moves the decimal place because of place value. That what you may have done, to avoid using a calculator perhaps, is you may have taken up in your percentage, so I'd like you to look back at your 9%, and thought about where the decimal was in that position. And we can always write our decimal after the last whole number. What does it mean to divide by 100? Well, we're going to lose our place value by 2 spots. So it's like I can move my decimal place 2 to the left. Now that opens up a place value. I can fill it. I don't want a naked decimal. And you can see up in the original problem, there's my 0.09. So for some of us, when we consider moving the decimal place 2 spots, that may be the fastest way for us to change a percentage to a decimal. There's some traps with that though, so I do warn you, be very careful. Okay, if you needed a review, there it was. I want you to pause it and finish off the last 3. Otherwise, you're coming along with me. So let's take a look then at B. I would hope we were okay to change that to 0.12. As I said earlier, you can move the decimal place 2 spots. Or get rid of my percentage, which means make it out of 100. Okay, you take a look at C. C can be a bit of a jam because you start to see a fraction inside your percentage. And I need you to know that's going to happen all the time. That quite often the way that percentages are reported when it's a part of a percent is to include a fraction. So when you guys see interest rates, quite often, it's usual to see 8.5%. My advice to you, I would take one line to go ahead and change that to 8.5. Just don't make the mistake that you see a decimal there and therefore you go, oh, okay, I'm good. Because no, you are not. That decimal is still a percentage. So all you did was change the form of 1/2. You didn't change the percentage into a decimal. Now that you have your decimal in there, maybe you can move that decimal place 2 spots or divide by 100, and we can come in on a 0.085. Okay, D would be our last one. I would hope that we are okay, that 3/4 is 0.75 because that's 75 cents. And now that you have that, we could change that to a 0.1375, and there is your decimal form. So hopefully not too bad, changing percents into decimals. That is going to be a key fundamental skill. We need to get practice at it. Okay, we've got another skill coming up. We got to make sure that we are good with days. I want you to take a look at your screen now. You'll take a look, and the problem has asked you to express as a fraction of a year for each. So I have given you 4 time frames, and I want you to change that into a fraction of a year. So how much of a total year, of 1 year, do each of those time frames represent? Okay, same thing as before. Let's pause the video and let's give it a shot on our own. Okay, pause it now. Okay, we're back. So this is one where I never asked you to reduce. So if you reduced, hey, great, but you never needed to. And I would be totally fine with all of these applications with you not reducing. So let's check on the first one. I would hope that for most of us, we just said, well, if I have to deal with months, then months, well, how many months are in a year? 12. 4 months then would represent 4 out of 12. When I mentioned reducing, if you gave me 1/3, hey, that's great, but not needed. Okay, if we cleaned up anything from the first, we weren't sure, hopefully that helps you. Make sure that we try the next 3 on our own. Otherwise, you're coming with me, and here we go. Okay, we already talked about the number of days in a year for financial math. That is going to end up dealing with 73 out of 365. If we talk about weeks, then the biggest thing was we had to know how many weeks are in a year. And there are roughly 52 weeks in a year. Be very careful. It is not required and it is not used. I would have had some people that would have said, hey, 5 weeks, there's 7 days per week. Well, then let's change that 5 weeks into 35 days out of 365. And you'll notice that those both do not match up. The reason for it is because there's not exactly 52 weeks in a year. If you took your 52 weeks and you multiplied that by 7 days, well, pretty quickly you can say 7 times 50 is 350. 7 times 2 is 14. That gets you 364 days in a year, not 365. We're 1 day off. So it's not exactly. The expectation for you is to use the time period given in the problem. So if you see 5 weeks, then use weeks. Now, what happens when you take a look at D? D has a mixture of times. And this is where you would be expected to convert to the lowest time period. So when you see, or I should say the smallest time period. So when you see that we have weeks and days, then you want to change that whole time period into days. So make a quick calculation first. 20 weeks would be 20 weeks at 7 days per week. And then we have to add on the additional 6 days. So 20 times 7 is a 140 days plus your 6. That is 146 days. We should be good then to say 146 out of 365 was the answer to that problem. Nice. So hopefully we are good with going through and changing time periods. Remember, we calculate interest based on years. If we don't have full years, we're going to need to break it down into how much of a part of a year we have. Okay, what I want to do now is I actually want to jump in and start calculating some interest problems. Like, let's go through and start dealing with interest specifically. Okay, here we go. Okay, you take a peek at problem 5, and I'll give you a moment to give it a read. Okay, we're back. So we see Raza received a scholarship from his work. He plans to deposit the money for 9 months in an account that pays 8% interest per year. The question A says, how much interest will Raza earn in 9 months? And I hope that we are good, that there is not enough information in that question to answer that problem. How much interest Raza is going to earn in that 9 months is going to depend on how much money does he earn for his scholarship. The 8% interest he earns is a portion of the money he invests. The 9 months that he's going to invest it for is how long it's locked in. For us to be able to answer that problem, we need to know how much was the scholarship for. So let's add that information in now. Raza receives, let's call it a $1,500, $1,500 scholarship. Okay, I want to let you work your way through problem A and see if that interest relationship is one that we're getting comfortable with. Okay? I want you to pause the video now, give it a shot. Okay, we're back. Okay, if having a formula to something is something that you like, if having a relationship to use to go through and deal with is something you like, then my advice to you would be write it down every time. It helps to drill it in. So my first line in that problem might be my interest relationship of I equals PRT, and I just jot it down first line. That'll help to drill it in. Then what I'm going to do is I'm going to start filling in the parts I know. Okay, I can break down the information in the problem. I have been asked to find what his interest is, so I need to find interest. Okay, that interest started with $1,500. I now need to multiply that by my interest rate. That interest rate was 8% a year, and I know I need to use my decimal form of that number, so 0.08. I now need to multiply that by the amount of time per year. Well, it was a part of a year. It was 9 months. And I know that 9 months is 9 out of 12 as a fraction of a year. There's my calculation. That's what I need to find. You'll get a moment to just double check that and make sure that we match up with the same thing. So go ahead and check your keying sequence. We should get down to $90 interest. Nice. Okay, I want us to go ahead and answer question B, problem B. I want you to answer it as fast as you can. Okay, pause the video now. Okay, we're back. So question B says, how much money will he have altogether in 9 months? That is us asking for the amount. So we need to take the original amount of the investment and add on the additional amount. If I was to ever ask you that question on an evaluation, I would be totally fine with you just telling me, with my units, my dollar sign, 1,590. I would never have to see how you got to that calculation. I think your reader should understand that. Okay, there we go. Hopefully we did okay. Hopefully that interest relationship is feeling comfortable. Here's where we're going to get a check. Can we now start to bounce around within that relationship? Okay, let's try another one. Okay, you take a look on the screen, and now you see we're going to ask a different type of problem. You have an investment of $80. There is your investment. That investment is worth $86 at the end of 1 year. This question is actually asking you, can you go ahead and find the interest rate? What is the interest rate that would pay that? Okay, here can be your snag. You guys start off, go, hey, wait a sec, I have a relationship for interest. I know that my relationship is I equals PRT. I know that. I've written it down a million times. I've drilled it in. And so now you start to plug in your information. Maybe you say, okay, well, my original investment was $80, so there's my 80. You look at interest rate was what the question was asking us to find, so I can't plug that in. I don't know what that is, and I'm just going to change the color on that if I can. I'm going to put that in red. My time happened to be 1 year, because I invested it for 1. And now my interest. Don't make the mistake of writing that, because that is incorrect. Now, why is it incorrect? Because I does not represent the amount of my investment. It only represents the interest. So I happen to think the easiest way to get there is that if we look back up into our original problem, you were told that an investment of 80 is now worth 86. Clearly, that investment went up in value. And what it went up in value is your interest. So how much interest did we make on that investment? We made $6. So there is our interest for that problem. Now, that might not look as familiar to you just because we have a bunch of operations in there. Like you take a look across that equation and you notice you have these old-fashioned multiplication symbols. Well, if I was to simplify everything I had on the right side, that is, I'm going to keep my 6 on the left, but simplify everything on the right side, well then I can calculate 80 times R times 1, and I can reduce that to 80R. Well, that should look more familiar now. You just have a good old equation, and you guys can solve that equation. How do you get rid of your times by 80? We should be good to divide that out. So the exact amount of that interest is 6 divided by 80. The only thing is we don't talk about it that way. So let's go ahead and let's change that into a decimal. So you guys go ahead and calculate 6 divided by 80, but then remember that is going to give us the decimal amount of that interest. We would communicate that as a percentage. So you go ahead and change 0.075, and your final answer to that question should be 7.5%. Nice. I'm hoping you guys can see if I put a little star beside that second line, we can build equations to problems and then use our equation skills to solve for parts of the relationship. Okay, let's try another one. Okay, now that we've gone through calculating interest, we've gone through calculating or finding another component of that relationship, I think you're ready to give problem 7 a shot on your own. So what I'd like you to do is to read the problem and then give it a shot on your own. Okay, pause the video now. Okay, we're back. So what would I do if I were you? This would be my first line. I read that question and I see I'm earning interest. It doesn't say that it's any other type of interest, so I know it's simple interest. I am going to jot down my simple interest relationship, I equals PRT. And now that I've done that, what I'm going to do is I'm going to plug in everything I know. Okay, so what do I know in the problem? Well, the problem says, how many months will it take? Well, that's asking me then to solve for time. So what I might do is, I might even write like a T there and circle it to say, I know that's what I'm solving for, so I want T to be in my equation. Okay, it tells me how many months will it take for 1,200. So 1,200 is my principal. And maybe if you didn't like setting up your equation last time with your old-fashioned multiplication, you can maybe deal with something I would argue is a little bit better. When you sub into a formula, get into the habit of subbing in with brackets around, because that's going to help you to maintain your operations. So I'm going to sub in my 1,200 for my P. It tells me that I'm earning an interest rate of 9.75%. So as a decimal, that would be 0.0975. I love having the T in there. That's what the problem asked me for. And it told me in the problem that I have earned $78 interest. Nice. Okay, that would be my equation. And if you built that equation, great. That's giving you feedback that you've interpreted the problem correctly. You are good to translate. Nice. Okay, now what I want you to do is I want you to try to solve that equation. So if we had a hiccup building that one, pause the video now and try to finish it off. Test your algebra skills. Okay, pause it now. Okay, we're coming back. So what we may end up having in that case then is on the right side, calculate everything you can. And so when you calculate 1200 times 0.0975, you're going to get an exact amount of 117 times t. If you were to multiply 1200 times that percentage and you were going to get something really ugly that required rounding, then don't. Do not calculate and round off. That's going to cause your final answer to be off. Leave it as is. Okay, this case, we get exactly that. We could now solve for t because you can take your 78 and to get rid of a times by 117, I divide by 117. Now, if you go through and you calculate that, you are going to get a t value that should give you a really ugly decimal across your screen. That is going to be 0.6 repeated. What that represents is years. Recall, our interest is always our time is always in years. The question asked you about months. So I haven't answered the question if I gave the answer 0.6 repeated. So what do I need to do to turn that into months? Well, then I need to go ahead and multiply that by 12. Now, I'm not going to write that line down because if I include that line and I just get rid of that years, notice this line that I put a star beside does not equal this line when I multiply by 12. So we just got to be careful. We really got to be careful. So if you choose to go through that way, then take that answer of 0.6 and off to the side, create a therefore statement. Therefore, it is 0.6 repeated times 12 that is going to give you the answer you're looking for, which would be 8 months. Nice. Okay, I want to show you a better way to get there. The reason why, what I did in the problem is when I set up my first red equation, I ignored that the question was asking me about months at all. And I just treated it as if t was generic, which meant time. I'd like you to look back up to the original now. And what I'm going to do is I'm going to slide that equation over, and I'm going to now answer the equation or the problem the way I would have. I'm going to take my I equals PRT, and I'm going to actually solve this now using the orange. What this is going to give me is a way where I don't even have to worry about my months. Okay, I make $78 interest. How do I make that? I make it by investing $1,200 at 0.0975 interest, and now is when I look at my time. Since the problem asked me how many months, I'm going to incorporate time out of 12, my number of months, right away. Right away. What that's going to now do is I just converted my time, which is generically in years, into months in my equation. So before, when I solved my equation, I had to hop out and interpret it with the pink at the end. Now I don't have to do that. I put my work in early in the orange. I will be calculating the number of months when I solve. Okay, what does that look like? Well, I would do nothing different. I calculate everything I can on the right side. Now, if I took 1,200, and I multiply it by that 0.075, multiply it by the t, divide it by the 12, then that is going to give me 9.75 t. Okay, how do I get my t all by itself? Well, then I need to take my 78, and to get rid of a times by 9.75, I divide by 9.75. And when I solve for t now, t gets me directly to my 8. All I have to do, put on my units. I know that I've already changed it to months, and there I go. Hopefully not too bad. So, key component between the red versus the orange solution. My red solution, I put no care about my number of months at the beginning. So I got to kind of shut my brain off there. But I then had to put the work in hard at the end. And for some of us, we may forget to do that. We may get an answer in the end and go, okay, I'm done, and move on to the next problem. And maybe we don't have the discipline to go, I got to make sure I check my time. You may not like the red solution then. The red said, I don't have to think about it early, but I have to consider it late. The orange solution is just different. The orange solution says, I'm going to do the hard work early and consider that time, but then I get to shut my brain off in the end. You decide what best works for you. Both, I think, are equally efficient. Okay, one last problem to check our understanding. Okay, you can see on the page right now, there is our last problem for today. I'd like you to work your way through and try to solve 8 all on your own. Okay, pause the video now, give it a shot. Okay, we're back. Okay, the only big difference maybe in question 8 is that I made it so your numbers were gonna get ugly. So let's see how it works through. You see that the problem is asking how much money invested at a certain amount will earn a certain amount of interest in a certain amount of time. Okay, that's a simple interest problem. I know I equals PRT. And now I can plug in all the information I know. Okay, what do I know? Well, if I scan across the problem, I see that I have $37.78 worth of interest. The question asks me how much money is invested. That means that for me to solve this problem, how much money is invested, I'm actually looking for P. So I know that's the variable I need in the problem. What was my interest rate? Well, it's 11.5%, so that is a 0.115 as a decimal. I earn that for an investment of 175 days. So my 175 out of 365 becomes my fraction. Okay, how do we now solve that equation? Well, first off, I think it's important for us to note, if you have the red on your page, then you understand how to calculate simple interest, you understand the relationship, you understand all the parts and how they fit together. Great. Take that as feedback. Now what we need is a little bit of feedback as to how well do we do when solving some of these ugly equations. Okay, the first thing you should always look to do, simplify anywhere you can. So we should be calculating whatever we can on the right side, nice and easy. As long as it works out nice and neat, no rounding. So you take a look on the right side, and we should be calculating 0.115 times 175 divided by 365. And as soon as we punch that into our calculator, we should be going, no, because you're going to get something hideous on your calculator screen. So maybe it's like we went too far. So calculate what you can. And what you'll notice is you can calculate 0.115 times 175 and actually get not bad of a decimal. That's going to work out to be 20.125 as a decimal. The only part we couldn't calculate, the part that made it really ugly, was the divide by 365. I'm going to argue to you, just leave it in there. Leave the operation in. Okay, you need to now try to get that p all by itself. And I want to hop out off on the side and make sure that we're good with what we actually have in front of us. I'm going to now just replace a bunch of things in my equation with some soft numbers for us to work with. Imagine the 3738 was like 20. Imagine my 20.125 on top was like a 5. And imagine my 365 on the bottom was like an ugly number, I don't know, 35. I don't know, something ugly like that. In fact, I even wrote it down ugly. So let me clean that up a little bit and just say 5 over 35. Something like that. Okay, if you had to solve that blue equation to get the p all by itself, I want you to see we can do two operations. First off, how do you get rid of a divide by 35? Well, we should be okay then to say, well, then I'm going to multiply by 35. So on that next line, I would have a 20 times 35 on the top of my fraction. But that's not going to get the p all by itself. I would still have that 5 attached to it. Well, how do you get rid of a times by 5? We divide it out. So I could divide that by 5. And that's how I can isolate my p. To get rid of my divide by, multiply out, like the pink. To get rid of my times by, divide out, like the green. So let's look back at my red equation now. If I want to get that p all by itself, then I can take my 37.38 and I can multiply out my 365, just like the pink, and then divide out my 20.125, just like the green. So hopefully that worked out okay. And now we're going to push some buttons. And since we are calculating a dollar amount, we need to know that we are going to round that to 2 decimal places if we need to. So you calculate that as a pretty ugly number. And you have your 0.38. Oh my goodness, I've been writing down the wrong interest rate the whole time. I really hope somebody caught that at the very beginning. I just hope it didn't throw you off the whole time and you're going, hey, Gray, excuse me, you copied down the wrong amount. Ugh. How about we go 37.38 and we multiply that by 365, then divide that by 20.125. And if you get an ugly decimal, which we do, we are now going to round, there's my dot above my equal sign, to 685 points, and we need to round to 2 decimal places. There we go. The only thing left to do, put on our units, and we are good. Nice. Okay, we talked about an awful lot of stuff today, going all the way back to what is interest, to then calculating interest, to then looking at the relationship of it, and getting some fundamental practice as we go, and finishing off with solving some equations. I think we did a ton of stuff today. Okay, your job. Work your way through the practice and make it as comfortable as possible with working with simple interest. Okay, best of luck.